Hi, my name is Jack McCauley. I'm an engineer. I am also a motorcycle enthusiast, and back here is my R1200 RT, 2018. I bought that in May of 2018 and immediately started finding problems with it, particularly with ergonomics, seating position, and comfort. So the first thing I changed on the bike was the handlebar position. And I went about trying to find handlebar risers, which bring the handlebars up so it moves your body back a little bit for the bike. And there are 3 different manufacturers currently. I wasn't happy with any of them. Today I'm going to show you a test I did on handlebar risers, which demonstrates some safety issues, I believe, with the 3 products. And then I'm going to do a demonstration with mine. I built my own risers on my CNC, which is back here. Test risers, and then I'm going to do a test on that to show you what the yield is. The yield is the torque that it requires to cause the handlebars to slip. No one wants to have a handlebar slip when you're riding. That was the first thing we attempted to tackle, was to eliminate any possibility that under reasonable load conditions that it would slip. So the 3 risers we'll be testing today are the Wunderlich riser for the R1200 RT, the Ilium riser for the R1200 RT, and my riser here. This riser is made from 7075, which is a high strength aluminum alloy. This is strong as steel. This alloy is then heat treated and is easily machined. Although it's not as soft as 6061, it's about the same cycle time, which means I can machine these just about as fast. And in this system here, what I have done is machined a small step onto this part. And this seats into the end of the handlebar with this special conical spring washer. And this is a German company called Schnorr. They make this stainless steel washer. And this grips it to the end of the handlebar when it's bolted. In this case, we use 50 foot-pounds or 67 Newton meter for our torque spec. Again, using Loctite blue and an M10-1.5 fastener. So this is the Ilium riser. I purchased this triple tree off of eBay. This is a 2014 R1200 RT, and this is the actual handlebar from a BMW. This actually goes in here like this, and then the handlebar grip is mounted here. In this case, this would be on the throttle side. This is the right side of the bike, looking from behind, looking from this part, and this is the left side. So the clutch is here and the throttle is here. So I'm trying to do is to determine how much torque it would take if you had your hands here and turned it, how much torque it would take to move it. You don't want it moving. To test it, I need to be along this axis here. This bolt here holds a pin that's inside of here. This pin here slides into the end of the handlebar. It's a slight press fit. And you probably need to put this, I froze it just as the instructions said. The first thing I did was froze it. I put grease on it, and I pushed it in and tightened the nut at the specified torque, the bolt, the specified torque of 50 Newton meters. To test this, I 3D printed this carbon fiber nut that goes on the end of the handlebar and allows me to turn the riser with a torque wrench. And I use a torque wrench to determine how much torque it takes to turn it. And that determines how much load it can take. So I have a torque wrench here. I'm going to place a torque wrench on the nut, and I'm going to begin torquing it to see when the riser moves. Right now this thing is set at 30 foot-pounds, which according to this is roughly 40 Newton meters, 45. And here goes the first part. That's 30, 40, 50 foot-pounds. It slips at 50 foot-pounds. You can see it slip. I'm going to call it 45 foot-pounds because it slipped very easily. I have installed the Ilium risers on the 2014 R1200 RT triple tree, and we're going to proceed with the torque test. Let me tell you how I installed it. I followed the online video by Ilium exactly. The only difference is there's no grip and no switch module on the handlebar itself. I just merely installed the handlebars. The lower bolt was torqued to 17 foot-pounds. The upper 10.5 bolt was torqued to 33 foot-pounds using blue Loctite. So I will proceed with the test. I have machined into a block of metal to keep this along this axis here, the footprint for the end of the bar riser, Ilium bar riser. And I'm going to place this on here. And I have a socket that goes on here. Wrong socket. I have a socket that goes on here. Hold on a second. It's the right socket. I have a socket that goes on here like this. I have my torque wrench. I'm going to start out at 30 foot-pounds, 40 foot-pounds, 50 foot-pounds, I'm going to go to 60 foot-pounds. It did move. So at 60 foot-pounds, it moves. So I'm going to call that 55 foot-pounds. So here's the riser that I made, and it's installed at the end of Handlebar. In the case here, I torqued it to 67 Newton meters or 50 foot-pounds. That's a higher spec than the Wunderlich riser, but in our testing it indicates that it's only 17 or so Newton meters more than the other ones. I doubt that would break. It's awful thin in here though, so be careful. You have to use a torque wrench when you install this. So the first test I'm going to do is I'm going to set this at 30 foot-pounds. I machine a nut that goes in a pocket in here that goes inside here so I can have a way of holding onto it. The axis is along the bolt, the fastener is down here. Small pin that inserts into the end of the handlebar, and the conical washer. So here's the first one. This is 30 foot-pounds. Okay. 40 foot-pounds. 50 foot-pounds. 60 foot-pounds. 70 foot-pounds. 80 foot-pounds. 90 foot-pounds. 100 foot-pounds. Now I'll really start cranking on it. 110 foot-pounds. It slips at 110 foot-pounds. I'm going to call it 105. Thank you, and ride safe. Don't forget to subscribe to my YouTube channel, Jack McCauley.